In this video, we're going to look at recognizing and understanding direct, inverse, and joint variation. Let's start with direct variation. As x increases, y increases, or as x decreases, y decreases. What direct variation is actually talking about is just a linear relationship. So whenever one thing goes up, the other thing goes up with it at the same rate. So if I have the number 4 on one side and the number 8 on the other side, I am going up at a rate of 2x, because we assume that if we're graphing this, that everything goes through the origin. An example in real life would be the equation of a circle. Since the equation for a circle is c equals 2 pi r, if you were to make your radius 3 times the size, your circumference would also end up being 3 times the size. The factor that determines how much increase is happening, how quickly the increase is happening, is called k, the constant of proportionality. And the equation of a circle, 2 pi, would be that constant that defines how quickly r makes c go up. I think you'll understand this better as we get through examples, but I'm going to jump into the next definition of inverse variation. So inverse variation says that as x decreases, y increases, or as x increases, y decreases. Every inverse function or variation is written in the form x times y equals k, or y equals k over x. This is probably the more common form to see it in. An example is that for a set distance, rate varies inversely with time. So the speed that you're moving is inversely related to the amount of time it's going to take you to do something. So in this case, the rate or speed is equal to some constant divided by the time. When you're graphing an inverse function, or an inverse variation, you're going to have something that looks like this y equals 1 over x graph. So a little bit of a strange curve that you can expect. Finally, joint variation. We're not going to actually graph this because the graph would be a 2D plane in 3D space, which would be hard to imagine at the moment. So we're just going to do this through example. It's just a direct variation with more than one variable. So as x or z increases, y increases, and as x or z decreases, y decreases. The function itself is written as y equals k times x times z. Best understood through example here. The area of a rectangle, where the area is equal to the length times the width, depends jointly on the length and the width. If you make the length longer, the area gets bigger. If you make the width wider, the area also gets bigger. You shrink either of those and the area gets smaller. And so therefore it's varying jointly on two different variables, length and width. Let's see if we can recognize these relationships in a few made-up scenarios. In this case, it says the time until the due date, which is t, and your productivity level, or p, can be roughly modeled by the equation p equals k over t. So what they're saying is that your productivity is equal to some constant divided by the amount of time you have. So if you have 5 days, you're not very productive. If you have 5 minutes to get something done, you would be very productive based on this function. Don't know anyone like that, but just an example. So what type of relationship is this? If we go back to our definitions, a variable equal to a constant divided by the other variable is going to be an inverse variation. Y equals k over x here. So this is an inverse variation. Next example. Test scores and time spent in math class can be roughly modeled by your test score, S, is equivalent to some constant times t, the amount of time spent in math class. What they're saying is that the more time you spend in class, the more your score is going to go up. What type of relationship is this? Well, if one thing causes the other thing to increase, then we know that we are dealing with direct variation because we only are dealing with a y and an x, two variables. So this is going to be direct variation. Last example here, the weight of all of the students in a school bus, modeled by W, can be roughly modeled by the age of the students and the number of students. So the older the students get, the more the weight of the students in the school bus. The more students you have, the more all of the students in the bus are going to weigh because you just have more people. So what type of relationship is this, where W equals K times N times A? Since we're dealing with two variables, and since both of them have a direct variation on the total weight of the students, we're looking at a joint variation here, this last one on the bottom. So this one will be a joint variation.